Hello and welcome to another video. This is 961842, May, June 2022. Today we're going to be solving this paper. In the last video we solved the variant 4.1. Okay, so make sure you download the source files from um, you know the question paper websites. Okay, so the source file will be required for question 3, which is named cardsvalues.txt. So the program uses a stack data structure. So the first question is basically an abstract data type question, and it stores up to 10 integer elements. The stack data is stored globally. The variable stack pointer stores the next available space. The first is going to be, so there it's initialized to 0. Okay, so question 1 underscore J22. So let's go ahead and open PyCharm and then create a new project. Okay, so let's just name this project May 2022 for 2. With that being said, you want to go ahead and choose the project location. Let's go ahead and choose the desktop directory, and in my case it's going to be this folder. This folder right here, which is May 22, because that's where I want to go and save this variant. Okay, just click OK. So with all that being said, let's just go ahead and just create the project. All right, so in the following folder, we should be having our project. Let's just scroll down to May 22. Okay, so it created a different folder for that. So since it created a different folder, let's go back to PyCharm. Okay, so I don't see the text files here. Okay, since the text file is not here, we want to go ahead and move the text file to this. So we should be, there you go. So we should be seeing the card values txt file because we need it. Okay, so let's go ahead and create a new Python file named question1 underscore J22. Okay, so we can go ahead and start, kind of coding the question. So I'm just going to go ahead and on the question. So we need to create stack data, right? So we need to go ahead and create a array named stack data. So let's go ahead and do that. So let's go ahead and go stack data. This is a integer element. It's going to be storing for x in range. It's going to store 10 elements, and we need to go ahead and create a global stack pointer, which is initialized to 0, holding the next available space. Okay, so this is part 1. So since we're already familiar with practicing on how to paste codes into the evidence document, I'm just going to make the process faster and not do that just for the purpose of this video. So write a procedure to output all 10 elements stack data, uh, elements in the stack, and the value of stack pointer. Save your program. So we need to write a procedure for this. So let's go and write the procedure. So def output, let's just call it output stack. So let's say it, now the question doesn't state anything about taking parameters in. And we know that these are global. So what we can do is we can just initialize them global inside the array. Stack data and stack pointer. Okay, so let's just go ahead and print stack data, and then for x in range for 10 elements. Okay, we want to go ahead and do for the number of elements in the stack, right? So we want to go ahead and do that. Then how many elements are there in the stack? So what we want to go ahead and do is, let's say for range, stack pointer -1, because stack pointer points to the next free element. Okay, so it points to the next free element, space. So what we want to go ahead and do over here is that since it's pointing to the next free space in the stack, what we want to go ahead and do in this case is just go ahead and print till the previous element, because that's where the data is stored, right? So you want to go ahead and do that. So for x in range, what we just do is just print stack data x. That's it. And we want to print stack pointer and just comma stack pointer. So that's going to be printing stack pointer. Okay, so that's going to be the solution for output stack. The function push takes in an integer parameter and returns false if the stack is full. If the stack is not full, it puts the parameter value on the stack and updates relevant pointer and returns true, right, for the function push. So let's just do push integer parameter. So let's just call it data to add. That's going to be the integer value. We want to write global stack data stack pointer. After we do that as global, we first need to go ahead length stack. So that's going to be the length of the stack. So let's just go ahead and write length stack pointer. Oh, sorry, stack data. Now we want to check if the stack is full, right? So if stack pointer, oops, greater than or equal than, a stack pointer starts from 0, right? So since it starts from 0, stack length is going to be actually 10 in this case, right? That's going to be the length of the stack. So if it's greater than basically greater than kind of the length of the stack minus 1 or equal to that, that's when we're going to be knowing. So what we're just going to do is length of stack minus 1. Okay, so if it is 9, that means we know that there's still an empty space. We want to just go ahead and do that. So length of stack minus 1, then return false. Else we want to go ahead and do is stack pointer, oops, stack data, stack pointer. So we want to go ahead and add the value there. Data to add, and we want to take stack pointer and increment it by 1. Oops, and we also want to go ahead and return true. That should be it for now. Right, so that's going to be the def push. So the procedure push is now taken. Edit the main program to test the function push. The main program needs to allow the user to input 11 numbers to attempt this to add to the stack. So 11 numbers, that's where we're testing push. And output it when the stack is added, and output a message when it's not added. Output the contents of the stack after adding the 11 numbers. So we want to add the numbers 11 to 21 later on. Okay, so we want to edit the main program. So for x in, so let's just, okay, let's just make it simpler. For I in range, this time 11, what we want to do is data to add. We want to take this from the user. So we take an integer as an input, add to the stack. Okay, and then what we want to do is call, name a variable successful, and then we want to just go ahead and call push with data to add. Okay, and then we want to say if successful, print data added, and if it's not successful, then obviously go ahead and print data not added. All right, so that should be it. And after this has been done, let's just go ahead and, okay, we don't need to actually print. All we can just do is just call output stack. That's it. Since it's a procedure, we don't need to kind of put it into sort of a variable. So that should be the second part. Not actually the second part, this entire part. Now we want to go and test the program. So what we want to do is we want to try to run this and see what's the result. So enter an integer to enter into the stack. So under 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. The stack pointer is 10. The stack data, this is all the data. Okay, so it's entering up till 19. It's actually doing it as a data not added. So we have a small error. So length of stack -1. Okay, that's working perfectly fine. So range stack pointer -1. Okay, we want to add, we want to print everything in stack pointer since it's starting from 0. So it's not going to be an issue here. And since let's terminate it for now. Since it's also starting from 0, okay, we need to do it. We need to actually consider the length -1 because length is starting from 1 actually. So that's totally fine. So now let's try to add 11, 12. Oops, I added 14 first. Let's rerun it. Stop and rerun. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. There you go, it's now printing till 20. So looks like our program is working fine for now. Okay, so output stack is working. So let's see what the next question tells us to do. The next question says the function pop returns -1 if the stack is empty, and if it's not empty, then returns the element at the top of the stack and updates relevant pointers. So we want to pop the function. So let's define pop. So the functions are always at the top. So def pop. Again, everything is global, so stack data and stack pointer. Okay, so I want to see that if stack pointer is equal to 0, that means the stack is empty. So what we want to do is return -1. Else, what we want to do is we first need to decrement stack pointer. Okay, minus equal to 1. Then we want to say that, let's call this top value. Top value is going to be stack data, stack pointer. We want to just keep that out, okay? Just put that in a variable named kind of top value. And then what we want to do is stack data. Then we want to do is stack pointer and assign that to 0 because now that's empty. And then we want to go ahead and return top value. Okay, so this is going to be the function pop. Okay, now the question says that after you write code you wrote in the main program for part D1, add program code to remove 2 elements using pop and output the updated contents of the stack. Okay, so after you've written this for D1, we want to go ahead and remove 2 elements. So let's just go ahead and do this. Print pop element, and what I want to do is just call pop. That's it, because it's going to be returning, and we want to do is, because it's always better to give some sensible output messages, even though the question doesn't require it. And with that being done, now let's try to run this once again. So 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. The popped element is 2019, and then we just want to go ahead and print stack data. Okay, there you go. This is nice and fresh. There's no issues with the code. It's running perfectly fine and smooth as we wanted it to. All right. So with that being said, that is done. That's kind of our first kind of question that's completely done. So let's move on to the next question in this. Okay, so 2D array stores data entered by the user. The main program declares a 2D array of 10 by 10 integers. Okay, so it's a 10 by 10 grid, 10 by 10 integers, and the array is initialized with a random number between 1 and 100 in each element. Write program code for the main program. Okay, so let's go ahead and do that. So we're going to be going ahead and on this, just create a new file named question2 underscore j20. Right. So we want to create the new 2D array. So okay. So okay. First of all, it says a random number between 100 and 1 and 100 in each element. So we first need, so since we're using Python, we need to import the uh, random library first. Okay, and then let's create the array. So the main program declares a 2D array. So let's see, does the following question, so the following question calls it array data. You don't need to name it array data because they never actually said anything about naming it. So let's just follow the question and just name it array data. So it's going to be a 2D array of 10 integer elements. I'm just going to go ahead and put this bracket. Then we're going to be doing times 10 actually, because this is a 10 by 10. So for x in range, and then we're going to do another 10. Okay, so that's going to be initializing the array for us. So with that being said, now it says it wants to initialize between 1 and 100. Okay, so let's just go to for x in. Okay, so we want to do for I in range 10, and then for j in range 10. Okay, since we want to initialize everything in that array with the random number between 1 and 100. So we want to do is go to array data I j, and we're going to initialize it with a random number. So random, so the code is rand int, and we want to initialize it starting from 1 till 100. So we got to do 101 because it's going to do up till that number but -1. So that's going to be, in this case, what you want to do is 101 in this case. Okay, you want to assign something to that, so it doesn't cause anything for the output. And there you go. So this single line of code should have done it. So now what I want to do is I just want to verify this, and I want to go ahead and print array data and see if it's running fine. Okay, it's going to be super big, so we just want to go ahead and ignore that for now. But since it looks like it's working fine. Okay, so once that is done, the following bubble sort pseudocode algorithm sorts the data in the first dimension of the 2D array into ascending numerical order. Okay, so what we want to do is array length till 10 for x. Okay, so they've given us a pseudocode for this particular. So amend the main program to implement this bubble sort. Since it's given us the pseudocode, we don't actually need to worry that much about it. So array length is 10. So there's a little right the menu program where we implement bubble sort after. You may not use any built-in sorting functions. Okay, so we can't use the built-in sorting function in Python if we could. So the thing is, we want to arrange array length 10. Okay, so array length is 10. So let's go ahead and bubble sort. Okay, and we want to take in the array as global. Okay, by reference so that the data is updated. So what we want to do is for x in range, and we first need to do the array length. So what you want to do is go do array length is length of array data. Okay, so length of array data is going to give us the entire thing. We don't do this. We just do the first column, so that's going to be 10. So array length. So in Python, when you write array data over here, when you have 10 over here, that means it's 0 to 9. But in pseudocode logic, you start actually, kind of from 1. So since they have started from 0 over here, it's going to count till 10. So that's why they did a -1 here. In Python, you need to do this. But if you're using something like, I don't know, C++, C++ or Java, I'm not sure about Java though, you need to do this -1, okay? But I don't think you need to do this with Java. I don't know if you need to do this with Visual Basic, since I haven't worked with Visual Basic. So with that being said, if you're using Java, you also don't need to do this actually. No, you don't need to, because in Java it's also from the logic of 0 to 9. You don't need to do this -1. But for Visual Basic, I have no idea because I haven't worked in Visual Basic for a long time. So for y in range, now since over here you're doing array length actually, why did I write array data? This should be array length. Oh, okay. Change this to array length. Array length, you need to do -1 here because we're doing -2 here, which is basically -1 -1. So of this, then -2. Okay, and for z, which is y minus 2, okay, we need to do y minus 2. So for x in range, you're doing a minus 2 here, so array length minus y minus, okay, let's do it with minus 1 and see if it is working. I'm writing x here again, this should be z. So what we're going to do is if array data x z is greater than array data x, uh, what's happening, array data x, okay, since we're doing z plus 1 over here, we might end up exceeding the range, so I think we need to do minus 2 over here, okay, since we might exceed the length. So then we're going to do temp value, alright, so temp value is going to be array data. Okay, since, oh no, we don't need to do minus 2 here because this is the same logic we're applying to this, right? It's going to be 0 to 8. So we want to do y then till that, kind of negative 1 over there. So this is coming from this right here. So I think negative 1 should be, okay, we're going to run this and we're going to see if we end up getting an error. If we do, then obviously we can go ahead and fix that later on. And in array data x comma z, we want to go ahead and put the larger value, which is x and z plus 1, and in array data x and z plus 1, we want to put the smaller value, which is the temp value, and that should be it. Okay, that's the bubble sort in this case. Temp value, we've got, I think we're getting some errors in here, right? So we're getting some errors. X and Z, then we've got X, Z plus 1, Z plus 1. Oh, we've got array length. Oh god, it should be array data. There we go. We still have a red highlight in temp value. This is interesting. Okay, so with that being said, now what we want to do is write program code to proceed to output all the to the values should be output as a 2D grid with the values in rows and columns. So each row and then each column. Okay, so write program code for a procedure. So let's just do def output array. Okay, um, let's go ahead and take. Okay, no need to take any parameters. Or you could, because over here it really doesn't matter actually. So what I'm going to do is do the global array data. I'm going to output it. Okay, call the procedure before and after your bubble sort code. Okay, so first we need to go ahead and write the procedure. So what we want to do is for x in range, we want to go ahead and do is again till array length. So what I'm going to do is just copy this. But this time, we want to do is we want to go ahead and also keep it as 10 because we want to output each row which has 10 elements. I'm going to tell you why in just a second. Each row which has 10 elements, right? So we want to output it as a tiny grid. So each row which has around 10 elements, and we want to go ahead and output that in that manner, so in that fashion. So for y in range, so that's going to be for our columns, which is also going to be array length, which is actually 10, right? So 10 by 10, and then we want to go ahead and output, so print array data x, and you want to also output array data y. Okay, so we want to go ahead and output that. We're going to put a space, and then we're going to do is we're going to put end equal to. Okay, so what we want to do is we want to end the function there. This end signifies, now if you want, you could end it with this particular function, which is this, what this is going to happen is this is going to print everything in a new line. If you remove this, it's not going to print everything in a new line, but it's going to be continuing to print uh, this exact same thing, all right, this exact same thing in the same line. So let's say for the first row, okay, for the first row, and then it's going to go to the first column, okay. So let's say you've got the first row of elements. So what we want to do is we want to go ahead and print out something like this, right? So I'm going to go ahead and print something like this. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 elements, and then we want to move to the next line. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So what we want to do is we want to first go to the first row. Okay. In the first row, and then we want to do is go to this particular area. This is the first column. Okay. So this is going to go to the first it's going to go to the first row of the array, and then it's going to, okay, so if you actually remember that how we printed the array, it's going to go to that first bracket of indexes, and it's going to output that, all of them in the same line, thanks to this loop, thanks to this loop right here. Okay, it's going to output this in all of them in the single line. Then it's going to break up of this for loop and then go to this for loop. When it breaks out of this one, it automatically will go to a next line. Okay, if you also want to do, like, let's say you wanted to go ahead and, okay, I don't want to do it on the next line, then you have to do what is go ahead and just do this print, and then again do this same and equal the function. You need to do that if you didn't want a next line even after that, but we want it to be in the next line, so it's going to go to this again, and then so on and so forth. Okay, so that's how we want to do it. So I think this program should work. So now what we're going to do is before bubble sort and after bubble sort. So I'm just going to go ahead and close this out to make it a little bit. So I want to do is print before bubble sort. Okay, print before bubble sort, and then we want to go ahead is do output array. Then I'm going to do is a print after bubble sort. I put 2 brackets here. Let's do with that. And then we're going to do is call bubble sort and then output array. Let's see. Okay, so we seem to have ran into an issue there. So it's not doing anything in a new. Okay, and then we've got after bubble sort. Okay, so we need to leave space for a new line. Okay, I got it. So this completely removes a new line from the array, but we don't want that. So when this loop starts, we want to start from the next line, right? So you either do it here or you do it here. But if you do it here, there's an issue. The first element is going to be printing out with the blank line. So we don't want to do that. We don't want to have an extra blank line for no reason. So what we want to do is we want to go ahead and print inside this for loop. After this one is over, inside this one, just print in a new, just an empty string. That's going to cause it to print in a new line. Okay, that should cause it to print in a new line. Let's see. There you go. Nice and easy. Can we do one thing? Can we put a tab space after? Okay, this looks much better. So what is this slash t? This slash t puts a equal amount of space, no matter how big that number is. Like, let's say you had a 3-digit number over here, like these 3-digit numbers. It's still going to go ahead and put in, or try to put in, an equal amount of tab space between them. So this looks a little bit neater, right? So we want to go ahead, like, it's just going to try to align these first digits together. It's going to align them, okay? So we can use that. Okay, we're having 101 here, so I think I was wrong about the random integer part. So what we want to do is change this to 100. There we go. It's now printing towards 100. So there you go. So in the bubble sort, it has sorted everything in the first dimension accurately and correctly. So our program is working perfectly fine. Right? So let's close all of these. Okay, so let's move on to the next part. Test your program. You take a screenshot. Okay, so the following pseudocode takes a function in the first row in the search value and in the search area and returns -1 if the item was not found, or returns the index where it is found. Okay, so now I want to go ahead and point out something. So according to the examiner report of this year, of this particular year actually, this binary search algorithm actually had a few issues. Okay, and that's why some candidates didn't get the actual output that should have been, kind of like got in the first place. So what we're going to be doing is we're going to be going ahead and just like, kind of study this briefly and try to, like, most part of it, the algorithm is correct. The issue comes is with this area and with this area. These are actually the only two issues in this algorithm after I've studied this. So we're going to go ahead and kind of try to work it out together and solve it on our own slightly, okay? So that's what we're going to be trying to do. So what we're going to do is we're going to do a def binary search. So let's going to do the binary search. So the binary search is going to go ahead and search only the first row, okay? In the first row of the array. So all I'm going to go ahead and do is, by the first row, what they're trying to tell us is, okay, past this for now. So what they're trying to tell us is that this first row, or only this first row, is going to be searched in the beginning. Okay, so since it's going to be a recursive function, it's going to be taking in a few parameters. So first is a search array, then it's going to be taking the lower bound, it's going to be taken in the upper bound, it's going to be taking in the search value. Okay, so first we want to see that if upper is greater than or equal to lower. Okay, but let's change this a little bit and say that if lower, because that's going to be the terminating condition, upper, so we want to return -1. That's going to be the terminating condition, right? Because it returns -1 if it's not found. Else, okay, let's go ahead and first go ahead and find out. Okay, so only if this is the case, it's going to go to the else section. But we also want to go ahead and try to find out, see every time if the mid value is found out, because this function is going to be called every single time. And if this becomes the case, the recursive call is not going to work properly. So let's just call mid and do lower plus upper. And then we want to do is div 2, obviously. This -1 doesn't need to be done because the div operator is automatically going to be rounding it down, so we don't need to do that. The div operator in Python is actually these double quotes, okay? So this is double slash. If you don't know anything about Python, what you can go ahead and do is go to this terminal. Oh, sorry, not the terminal, actually. You should be going to the Python console, not the terminal. That's different. In the Python console, type in help. And then over here, you can go ahead and there we go. Just do this double equal to, and then you should be finding, okay, there we go, right here. And then it's going to be going ahead and division, there you go, division, floor division. So floor division, so in mathematics, you should be familiar with floor functions and ceiling functions. Floor functions are the ones that, kind of, so if it says floor division, that means it's going to be dividing the number and rounding it down to the nearest integer. If it said a ceiling division or a ceiling function, it's going to be rounding it up to the nearest integer, all right? So that's going to be a ceiling division. So just be familiar with these mathematical terms, and you can interpret all these help sections in Python. All right, and you're allowed to use this in your exam, so don't worry if you ever need to. So if search array, so we're going to be searching the first row, that's going to be 0, and we want to search starting from the mid section, is equal to search value. Okay, then we want to return mid, because that's going to be the index we want to do. If that's not the case, we want to go ahead and see that if search value 0, and then what we're going to do is mid is greater than the search value, what we want to do is we want to go ahead and return the value from binary search. We're going to take search array, but this time, since it's greater, that means it's going to be in the lower boundary. So it's going to be mid -1 and then search value. And finally, if that's also not the case, then we can just do an else. I'm just going to copy this. And this is going to be upper, and this is going to be mid +1, because that's going to be in the upper section, right? And that should pretty much be our recursive binary search, okay? Just follow this algorithm to kind of go ahead and be short to kind of do this. Okay, so once that's done, it's in the main program, test the function binary search twice, outputting the return value each time. One to should be that's in the first line, and that is not in the first line, okay? So we need to go ahead and obviously print, the value. So let's just call it first check. So we want to go ahead and do is like the first value. So what we're going to do is just go ahead and int input and let's just go ahead and kind of copy this and name it second check, and let's call this second value. After that is done, we want to go ahead and just go ahead and print x. So let's just call it x, obviously, and this is going to be array data. So the lower bound is going to be 9, the upper 0, and the upper bound is 9 because it's got kind of 10 elements, so 0 to 9. And then we have to do the search value. So the search value in this case is going to be first check. And let's just copy this. Second check. And obviously this is x. Oops, I opened the AI area. Y. Let's just call it y. Do we have y in any other? Okay, we've got I, we've got x over here. Okay, that doesn't matter actually anymore. So print so if x not equal to -1, print not found. And we want to do this similar thing for y. Just do it with y, right? And then we want to just do over, in this case, we want to do y, and we want to do x. All right, so this is going to be a sensible check. So now we want to go ahead and do the first. So let's do 22, okay, just as a test. And let's do let's go 78. Let's go ahead and do 77. Okay, so we've got this in the first check. The integer object is not oh, okay, hey, oh crap. So why did I do search value? Oh, search array. Okay. So this time we've got 22 again. So let's go and just do 22. We've got 7, so let's just go ahead and do 77 once again. Okay, we have another issue. Greater than is not support for the instances of integer and a list. So we've got search array. Okay, oh, great. So search array greater than search array. So that's the mistake I've made. So what I'm going to do is it's a search value. Let's do it again. I'm doing it a couple of times. Let's do 36 this time. 36. And once again 77. Index found 3, there you go, 0, 1, 2, 3, there we go, and not found. So the code is working perfectly. Okay, so with that being said, this is the code for the one. All right, let's go ahead and do the last question. I know, and it's going to be named question 3 underscore J22. Okay, I'll make sure I'm recording. Okay, it looks like I'm recording. So let's move on. So question 3, we're going to be going ahead and doing a object-oriented programming. We've got a number. Okay, so program designed to a set of cards, and it has the data of the cards saved in card value.txt, card values, and we've got the card class. Okay, the constructor takes in the number and color of the card as a parameter and sets them to a private attribute in this case. Okay, so with that being said, do not write any other methods. Okay, so first we need to go ahead and define class. So the class card. So in this, let's just go ahead and first do the constructor. So it takes in two values, the parameter, and sets them to the private attributes. So number and colors. So it's going to be taking number p and card p as parameter. So let's do a private self dot number and self dot card is going to be card p. Okay, so that's the first part. The second part is we need to write the methods of get number and get color. So it's just going to be returning the number and color. So def get number, so it's a self. Then we've got return self dot number and def get card self, obviously, return self dot card. Okay, return self dot card. So let's move on to the next part. The text file card values.txt stores data for up to 30 cards in the order number, color. For example, 1 is the number and red is the color. A one-DRF type card is declared to store all the cards read from cards values.txt. Okay, and it's of type card. So write the main program to declare an array type of 30 elements and read from the card values.txt. Okay, so let's go ahead and call these card data. And this is going to be of 30 elements, but we don't need to kind of mention this right now. You could write it at a comment of just mention that in a comment. So once you have mentioned that in a comment, you can go ahead and do that. And then what you got to do is write a main program and read all the values from card values.txt. All right. So what we want to do is try okay, except IO error. And in file, we always need to do a appropriate exception handling. So file not found. That's actually expected from the syllabus. So what we're going to do is just open this as a file, card values.txt. We want to go ahead and open this for read. So what we want to do is we know that there's going to be for 30 data. So for x in range, we're going to do is 30 over here. So what we want to do is we want to first do the number and the color. Okay. So number. So we want to do is file dot read line, and since they're in each new line, we're going to use a strip command, and we can't use the okay wiring card should be color is going to be file, got read line, and then we've got the strip function. Okay, then we're going to create the card object. So card object is going to be a card class, obviously, and then we're just going to put number and color. And then what we just need to do is we just want to do is card data dot append card object. Okay. So all the 30 elements is going to go inside that array. Okay, that should be it. So once that's done, what you can do is the program needs to allow all the players, maximum of 5, to select 4 cards from the 30 available. Okay, so there should be no more than actually 5 players actually. So what we want to do here is the function choose_card takes an input and integer to represent an array of index from 1 to 30, validates the value that if it is from 1 to 30, and checks if the card is available. That means it has not been selected. Loops on the available card circle and returns the index of the card if it is available. Okay, so it first needs to go ahead and take an integer as a parameter. So def choose card, yeah, choose card. Input as an integer. Takes an input as an integer. Okay, so obviously what we're going to do is user index. Let's just call it that. Int input. And this must be validated. So let's go ahead and do a while loop. While true, if user index is greater than or equal to 1 and user index is less than equal to 30, break. There we go. Simplify chain, all shift. Okay, so we can just go ahead and okay, so that's going to be doing it for the first part, and returns the index of the card if it is available. Okay, so what we want to do is validate if it's okay. So we have validated it. Now it checks if the card is available. It has already been selected or not selected. Okay, so if the card has been selected or it is not being selected. Okay. So what we want to do is we want to see that if a card is selected or not selected. So what we want to do is once we put an integer of 1 to 30, we could go ahead and create a different array to store, cards that have been selected or that have not been selected. Or what we could do over here is use the array card data itself. So I'm going to first try to just go ahead and use card data itself. If it doesn't work, then we're going to be going ahead and doing the array solution. So what we're going to do is just do that if card data none, then what we want to go ahead and so what we want to do is loops until an available card. Okay, so we want to also loop, right? So what we want to do is let's just call it flag false, loop flag actually. true, print not available, and then you want to go ahead and just okay, so I'm just going to do that inside this if statement. Else, if it is not none, then we want to go ahead uh, return the index of that array. Okay, so we want to return the index of the array. So what we want to do that if that is indeed selected, what we could do is that if it is not selected, then what we could do is go to hard data. User index is going to be changed to none. Okay, user index. And what we want to do, user index -1, because the index is -1 because in Python or in array it is kind of 0 to something, right? Why is user index a little? Oh, okay. No, I want to ignore this. What's the error here? Incorrect type. Hard data. It should. Okay. We'll see. We'll see what we can do. If this is not working, then we have to go ahead and do the array approach to this question. I feel like the array approach is going to be a little bit more trickier, so I just don't want to do that. And also, let's do user index minus return that. Takes an input, returns the if it is available. Right? So if we want to do so while loop flag. Oh, and we need to also stop the loop. So that's going to be loop flag is equal to false. If a selected card is okay, so if it is none, then it's not available. Else it is available. So while true, we take another input, and if it is not none, then we just go ahead and do loop flag is false. That means it is available. We just want to return it, and also change that to none. Okay, so with that said, now what we're going to do is we want to just go ahead and select all their 4 cards, amend the main program to create player 1 of type card, ask the player to input 1. So obviously, okay, let's just do is player 1. So why are we doing an array? Because we need to go ahead and store cards in player 1. And the question has said it's an array. So to input, as a player to input it from, integers from part 3D. Using the function from part 3D. Okay. So I want to input 4 integers. Okay, okay, so this choose card should be called 4 times. So for I in range 4, choose card. So I just want to go ahead and do choose card and store the cards in player 1. Okay, so there is a problem. The problem is that if we make it none, we cannot go ahead and kind of store the selected, like we need to output the selected cards. If we just kind of convert it to none, there is going to be an issue here. So what we want to go ahead and do is we can either go to an array approach or just amend the main program itself. All right. So using functions. Okay. So what we want to do is let's just go and output the number and color of cards in player one. Okay. Print store the cards in player one. Okay. Store the card. Okay, so store the cards in player one. So it must be storing this in the array. So I think we need to take the array approach. So if you need to take the array approach, then what we got to do is we got to go ahead and create a new array. Selected cards, and this array should be of kind of 30. So for 0 times 0 for x, 30. All right. So while true, okay. So loop flag, and we want to do is just global this up to selected cards. And what I'm going to do over here is, okay, so while loop flag, so it's going to be kind of going on looping. So when it's in the loop flag, so if selected cards, then you got to go is user index minus 1 is equal to, okay, is not equal to, because if it's equal to 0, that means it is still available. If it is not equal to 0, then it's not available. Else, what we want to do is loop flag is false. Then we want to do is we want to do selected cards user index minus 1. What we want to do user index minus 1. We want to go ahead and change this to, let's say, a 1. Okay, meaning that that card is available in that particular index. So loop flag is false. I don't know why this is grayed out for now, but we're just going to call it choose cards. And it's going to be returning user index minus word. So chosen card is going to be that return index, right? So that's, and then it's going to be equal to minus 1. So if it is not equal to 0, that means it is not available. And if it is 0, that means it is available. So it is available. Okay, so it's going to be it. Otherwise, it's going to be 1. So it's going to be either zeros or ones in that array. Okay, so chosen card, choose card. And then what we want to do is actually want to input 4. So store the cards in player 1. So what we want to do is player 1 dot append. And what we want to do is we want to go to card data and go and just append it to chosen cards, right? Because that card is going to be now stored into player 1. And once that's done, so we want to do another loop is for, let's say, for j in range of the 4 cards, right? Output the number and color of the 4 cards in player 1. So print cards in player 1. Output this. Then we want to do is we want to go and print player 1. Then we got to do is j dot our number, and we also want to do is card color, and also what to do is player 1 j dot uh, get color. Okay, so I think I made a mistake over here. I wrote it as get card. This should be get color. There we go. So with that being said, I think this should be enough. Range full. Let's see what happens. Enter. Okay, it's asking me to enter. Let's try 1. Let's try 5. Let's try 9. Let's try 10. There you go. Nice and smooth. That's been added. And if you want to run it again for test 2, not available. 3, 4, 4, 5. Okay, and this also runs smoothly. So we needed a secondary array because otherwise, if you just do to none, you could go ahead and just output it from the original array. But the question has specifically stated we need to store it in this player1 array, which we wouldn't have fulfilled if we were doing that. You could again like just take the printed values and then create another card object and then do it. But I think it's just a little bit more efficient just to do it with this. And with that being said, this is the end of the paper. Hopefully you enjoyed, and I'll catch you up in the next video. Peace.